Now, looking at these inequalities algebraically, we remember that this inequality could actually be broken into the inequalities x less than or equal to 6 and x greater than or equal to negative 6. Well, that sort of thing would apply no matter what's inside the absolute value signs. If you have an absolute value less than or equal to 6, then whatever's between those signs has to be less than or equal to 6 and also greater than or equal to negative 6. So that if we have absolute value of x minus 1 less than or equal to 6, we can interpret that as saying that, well, whatever's in here has to be less than or equal to 6. What's in here is x minus 1, so x minus 1 is less than or equal to 6. And also whatever's in here, if it's going to have an absolute value less than or equal to 6, it better be greater than or equal to negative 6. Well, again, it's x minus 1, so x minus 1 has to be greater than negative 6. It has to be both. It has to fit both conditions. Just saying that it's less than or equal to 6 means that, well, it could be negative 700, and that wouldn't fit the inequality as stated. And then these two inequalities, we break this absolute value inequality into two inequalities, and each is very easy to solve. So we get our x less than or equal to 7 and x greater than or equal to negative 5, which is, of course, in agreement with the interval as we graphed it. We could do the same thing over here, and I did it. X minus 3 has to be less than or equal to 6, and x minus 3 has to be greater than or equal to negative 6. If it was not less than or equal to 6, it would be greater than 6, and the absolute value would no longer be less than or equal to 6, etc. Okay, and then those inequalities are easily solved. Now, there's another type of situation where you have a greater than or equal on the inequality, and we'll talk about that just a little.